So problem number 24 gives us this diagram, and what we're given here is that angles A and H are congruent, that this side here, BC and CG, are congruent, and it's pretty obvious that our attention's being called to angles 1 and 2 because they are vertical angles, and therefore we know that they are congruent as well. So what we've got here is we're given an angle, and a side. And here we're giving an angle, and a side. But notice that you might say right away, well, this must be angle, side, angle. Okay, because that might be your first thought, that this is congruent because of angle, side, angle. But no, because this is not an included side. Okay, we haven't yet shown that angles G and B are congruent. But they are, right? Because if two angles are congruent, then so is the third. So what this is really angle, side. Okay, so the congruence here is angle, side, because we proved that basically it's the same thing as angle, side, angle. Okay, so we could go ahead and we could draw in the remaining congruent angle, and that would make it angle, side, angle directly. Or we could leave it out and just make it congruent because of angle, side. Either way, we can go ahead and state that triangle ABC is congruent to triangle HGC. And I hope you see why those are the particular letters. Going over to problem number 25, we've got an interesting case where we've got two sides that are congruent. We've got side AB is congruent to side CD. Side AC is congruent to side BD. So we've got side and side. But do we have enough? We have two sides. Do we have enough to say that these two triangles, the one on the top, ABC, and the one on the bottom, BCD, are congruent? Is there any way we could say that an angle, any of the angles are congruent? Well, we're not given that any of the lines are parallel, and there's no way of telling that the angles are congruent. So it is yes or no. Are these congruent triangles or not? Well, if we're not sure, let's go ahead and separate them out again in our minds. Let's kind of separate these two triangles. So we've got A, B, and C, and we've got B, C, and D. And we know that AB and CD are congruent, and we know that AC and BD are congruent. But now it might be easier to see that CB is congruent to itself. Okay, which we could have marked up here by just putting a little X over it. So in reality, these two triangles are congruent because of side, side, side. Okay, so we can say that the reason is side, side, side when we remember to include the shared side CB, and that our triangles that are congruent are triangle ABC in the first triangle, the one on the top, but A is opposite the triple marked line, which would make it correspond to D. B is opposite the double marked line, which would make it correspond to C. And then finally, C in the first triangle is opposite the single marked side, which would make it correspond to B. So don't get fooled by the letterings here. ABC, triangle ABC, is congruent to triangle DCB. So C here doesn't necessarily correspond to C here, and the A here, rather the B here doesn't necessarily correspond to the B here, because you've got to look at the particular triangle and what side they're opposite. And I think just by looking, you can see that in the top triangle, for example, C is opposite side AB, which is congruent to CD, which is opposite B in the second triangle, which is why C in the first triangle becomes a B in the second triangle.